All right, so we realized what was going on with compressed sensing. It turned out to be two things. One, we weren't running PDHG long enough, and two, we needed to vary the um, value, the bound imposed on the constraint. It's very strange for me to see myself this way. So that's happened. Great. I thought I had a solution by using a weighted norm instead of just a regular norm. I was able to find code to project onto a weighted ball, and that didn't work. So what to do? Now, remember, this is all compressed sensing that we're working on now, but this project was about SPIRiT regularization. So the thing to do might be to just not worry about making it parameter free and just go on to implement SPIRiT regularization. That's probably what I'm going to end up doing, but there's one more thing I want to check first. So my question is, after this polishing step down here, so image 0 here is what the compressed sensing without sensitivity maps does. And then this is the result, I guess, this is the result of using the sensitivity maps. Okay, so if we, I don't know how many n we've got, 10,000. Probably don't need 10,000. Let's go to 1,000. We're at 280 already. Okay. So the thing I'm checking, that's the result that gets passed in. Like this is the result of not using the sensitivity maps. And after 500 iterations, oh my goodness. And mind you, this result is not horrendous. It's not great, but it's not horrendous, right? It's not bad even. My question is, after we do this step, do things get better? Because we've already done this where we found one image that was most consistent with the sensitivity maps. So what I want to know is, how does that image compare to image 0? And how does the result of this polishing step compare to the result of this making the image consistent? That's what we're going to look at. Okay. Is that better or worse than this. Worse. The difference is subtle, but it is worse. Okay? And then how does this result compare to just this? So LSQR is doing nothing. It's not changing this in any meaningful way at all. And then, as we already said, the results of PGHD is worse. So we could just keep this. Okay. Previously found that epsilon S maps of 1 times 10 to the negative 7 gives us a good answer. What about 1 times 10 to the negative 8? And another question is, what is the noise variance? What is epsilon? 3 times 10 to the negative 11. Now, the violation might not go to some reasonable amount. At some point, it just might be infeasible. At some point, it will be infeasible. So what to do? What if we just made it as small as possible, but also feasible? How small can MFS x minus b be? We've done this before, but we realized we weren't running PDHG for a reasonable number of iterations. SPIRiT is now 1.7. Violation is still high. That looks good. Okay. I'm going to put back the How small can it be and still be feasible? Just so we can have a bit of a success, let's add that to do checks. Where's do checks? Here we go. Okay. One less thing we have to worry about. Call this feasible image or LSQR image. Hmm. Okay, it runs. What's the issue? Arrays have incompatible sizes? What is this image not? I forget how to use. That should be B. A, B, 1, 2, 3, 4, then image not. A, B, 1, 2, 3, 4, then image not. Great. I think that was the issue. Okay. One times 10 to the negative 6. 2 times 10 to the negative 6, actually. LSQR did not converge. Failure. Okay. 1, 2, 3, 4. The fourth one is the maximum number of iterations. 3 and max iter. Where is it? 100? Guess we're going to 1,000. What's the flag now? 1 still. Still 1 times 10 to the negative 6. Why isn't it converging? And if we set this equal to 10,000, so running it longer and longer. Okay, it finally converged in the 1030th iteration, but it doesn't matter because it didn't change the answer much. It's not shocking. We set image not to image. Converges 3 iterations sooner. So this is the lowest value it could be and still be feasible. 2 times 10 to the negative 6. 1.7 times 10 to the negative 6. What does PDH do when the problem isn't feasible? ChatGPT, the thing that's oh so often wrong. So ChatGPT has no idea what it does. And I'm guessing that is worse than the LSQR image. No, not the LSQR image, but image 0. One's ever so subtly better. Image is better. Subtly better. But better. So here I'm setting epsilon S maps to the noise variance. This result, this is an infeasible problem. According to ChatGPT, sometimes it'll find like the best solution in an infeasible region, whatever that means. I wonder if it'll get as close to feasibility as it can. Sparsity of 1 times 10, sparsity of 1.6 is about right. This is a sparsity of 1.7. We're at 1,000 iterations. We're still going. Looks like we've reached the limit of about what the violation will be. That is excellent. Let's ask ChatGPT again. This time I'll actually read the thing. Maybe I could just look up the answer here. Might minimize the objective function as much as possible within an infeasible region. This can lead to a residual error that does not go to 0. That's what's happening. And the thing is, that result is great. Okay. This is how we're moving forward, and we're going to try and justify it at some point in the distant future. We'll call this thing image not. Sparsity was 1.9. 3.5 times 10 to the negative 11. If you do projection onto convex sets with momentum, but the sets are disjoint, I think you end up in the middle of the two sets. That is, you end up on the line, the shortest line that connects two sets right in the middle. I think that's where you converge to. Which isn't a bad answer, right? Like that's an answer that you would want. I don't think PDHG accepts these metric values, but maybe it should. So PDHG outputs X star objective values relative diffs. PDHG with line search X star objective values metric values. I'm calculating the relative diffs. Do I need to? Oh, this is just the function. Yeah, it's a little too hard to get those two things jiving, so instead, just going to move these things in here. Does that work? What on earth? Oh, because it's first doing this. Okay, I think the answer is obviously going to be yes. But I think the image that this comes back with is going to be very different than the image that this comes back with. All right. All right, now what? Now it looks like we've got a compressed sensing algorithm. A couple of things to do. Add in the support. Add preconditioning. Add warm start. So where does the support go? What do we even call this? Apply P maybe? Apply P. Okay. Now it's weird that like, okay, I put this in the wrong spot. No, I didn't. This is solving a different problem than this. We can't have a metric here. Oh, okay. Not going to worry about it. Everything's going fine. This isn't what I want to do right now. I guess prox G is showing an error here because, and apply A because they're always defined no matter where we go, and that's fine. I guess G is not, oh no, it is, yeah, okay. Great, 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 great. Maybe we should just delete these. And those. Let's add in the support. I'm going to have to take a break for a moment. Huh. Okay. What is P? Oh, I see. This is the support when the noise variance is 0. So P takes the image and returns just the values within the support. Okay. Takes the image. Okay. Think that does it? Let's do checks on that. Okay. Okay. P passes. Now here, oh no. Yeah. And support. And support's not defined. Does it send you checks? Yeah. Okay. Passes. Uh-oh. Hmm. This is using Fisto, right? Okay. Why isn't that? Where's psi? Is that a bug? See what Fisto does when we fix that bug. It crashes. Variable undefined. Prox G. Why is that? Because I named that one Prox F. Okay. That's worse. That's significantly worse. That's great. Okay. Actually, Might be better to do -1. Yep, that's great. Okay. Okay. So there was a bug in what we were doing with Vista. I mean, goodness gracious. Still broken. Power iteration. Mm-hmm. X naught must be non-zero, right? Sorry. Okay. P psi? This needs to be PT. And that makes it no longer orthogonal. Oh. We can move this from here to here. Okay, we need this. So if we let y equal ptx, no? What on earth? How do we do it over here? Put it in with I put it in with fs. But then what? Oh, because I didn't do compressed sensing over here. So we're going to need Vista for this. I mean, PDHD for this. This is getting pretty hard. Yeah, that's the answer. If numL support is greater than 0, else and rather here. If numL support equals 0 and OSI is true, then we can use Vista. Else if numL support is greater than 0 and OSI is true, now we're going to need PDHD. Why? Because if n coils is greater than 1, else end. PT, PT. Does it matter if OSI is true? No, it doesn't matter here. And psi PT. All right, let's do some concatenations. Okay, as you can see, things are getting much more complicated. Good night, my beautiful girl. I'll see you later. I'll see you. As I said before, I'm a very lucky man. Okay. No, this is just going to be S image. Okay. Let's do checks. We're going to do all the concatenations, I guess, if abnormalis maps okay. Hey. It ran. Oh. Still broken. That's why we do checks. Ooh, this is doing PT twice. Now here, apply M. Sample mask equals 1. Okay. So we're zero filling the k-space data here. Now we're going to do the inverse is the adjoint of the Fourier transform, which is a scaled inverse Fourier transform. Now we're going to do the adjoint of the sensitivity maps. So this thing is going to be 256 by 256, right? And this thing is going to return something of end support. 46614, 46614. That's this. Okay, we could do this. Out 1 is equal to apply MFS in 1 to NB off. Out 2 is equal to apply, or psi reshape in NB plus 1 to end this image up. Out is equal to apply P out 1 plus out 2. I think that's the same thing. The thing before wasn't working, so let's see if this does any worse. Ah, it passes. Okay. We made it faster and it passes now. I have no idea what was happening. I don't know. Is this called anywhere? Other than there? Nope. We'll keep it around. Never know when we might need it. Okay. I don't do that really, do I? It is weird though. I'm going to keep it around because I believe that check is doing something for me. Okay. Crashing. Variable, unrecognized function of variable x naught. Equal to does that work? I guess it does work. Then I want to take that and multiply by the support. Okay. F and prox F are not defined. G MFSBT, look at that, plus lambda Now we need the prox G. No, this... Prox L2 squared. In TV plus in 1, 2, NB prox L1 complex. I should really just call that prox L1, by the way. Lambda times C. Okay, did that work? I'm calling it X naught or image naught? Okay, I don't want to multiply by the support. Instead, I want to apply P. Okay, and the norm of A is 256. Why did that crash? Undefined variable or function prox F. I thought we didn't need it. All right. Arrays have incompatible dimensions. Two, 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 8, 2, 4 by 1. A huge array, right? Wait, what just, okay, wait. What just happened? X is 4661. But where was it crashing? It's crashing in G, right? Maybe not. Okay. What just happened? Keeps doing that. The DSC value is 0, so it's exiting, which is clearly not what I wanted. Stop checking adjoints. Is it set to true by default? Yeah. And not is a, let's see, function. Oh, function handle. And DSC equals true. Okay, let's do that. So it's relative difference. Num of f is equal to 0. Optator is equal to 1. Save function's empty. Save array is empty. Okay. Y is 0. Arrays have incompatible sizes. My goodness. Oh. It's the separable sum property, which means we do not add them. We concatenate them. Wow, is that taking a long time? N unknown. What is that? Oh. Objective values going down, DSC values going down. Sort of. Where does Y get initialized? Apply A. This would be like MFS, for example. I wonder, I must have tried just apply A at some point, and that didn't seem to work well, so then I just set it to zeros. I wonder why, though. Okay. ML, Y, and support. Okay. So now I got to do else if numl y is equal to n support, image is equal to apply p y transp. That looks pretty good to me. That looks pretty good to me. Let's make sure. Yeah. And that is the output. Okay. We've got this one. With the support, if the number of coils is greater than 1, and noise var equals 0 or noise var equals 0. Do I call it noise var? Yeah, okay. Epsilon. I call it epsilon. Gonna have to update this quite a lot. Let's do that now. If epsilon is also supplied, then minimizes. This is the one we're going to work on next. Oh. No, that doesn't make sense, does it? Okay. Yeah, we're going to need to add support to the single coil. PT here, PT here. I think that's what we're going to have to do. Okay. Protost! Man, how's it going, Protost? He says his car is driving him. It's shocking how much that doesn't shock me. Like, I'm just like, oh yeah, a car driving itself. What'd you expect? Okay. This is getting to be a beast of a code. I guess you would never provide the constraint on this value and lambda because that just wouldn't make sense. So this is, we've got these two to go, and then of course we've got all the ones where the number of coils is equal to 1. I guess we don't need that. Oh, this is the one I'm talking about, I guess. Seems like we could have that one done pretty quickly, doesn't it? Wasn't gonna do it, but now I will. So I guess this is the same. And this is the same. Why is that happen? Oh, because I've got this error here. So now I just need concat. I think that's it. Oh, well, I could have done that, but error. Wasn't going to do this today. Guess we're doing this. Oh, because there's an S right there. Wait, why was there an error then? Okay. Good. Okay. End-to-end on highway is a big improvement. Difficult to get car to understand HOV lane. Oh yeah, are you trying to say it wants to go into the HOV lane, but you're driving by yourself? That's interesting. That seems like something that Tesla would have figured out, given that they're from California. Or that they, a lot of them are from California. Now they're from Texas, I guess. Yeah, that's interesting. Is a big improvement from when? Like, did you recently get an upgrade? There's this fact where if Tesla gets um, full self-driving up and running, actually full self-driving, like you don't have to pay attention at all, totally legal, cars without drivers on the road, then it'll be cheaper. I don't think the neural network knows how many people are in the car. That's funny, but it should though, because my car, for example, knows when somebody's not wearing their seatbelt. There are uh, there are scales in each seat, and if there's something that's too heavy in the seat, it says the person needs to wear their seatbelt. So it could. Okay, that's what single coil data with the support does. Doesn't shock me. It's running and makes an image. We've got one more case implemented. Now here's a question. End-to-end on highway is recent, past couple weeks for me. Oh, nice. Maybe it does now? Well, then why is it trying to go into the car lane? Do you have a super heavy bag in the car seat next to you? Is it telling you that a seat needs a seatbelt, even though there's nobody there? Anyway, there's this fact that it'll be cheaper to just let your car drive around incessantly than to pay for parking in cities, which will, of course, increase the amount of traffic without taking anybody anywhere, just to hold off on paying for parking. We found a bug today, Protost. It had been staring at me for a long time. All right, what is this if? So if the numel support and OSI is equal to true, numel support is equal to 0. Else if what? Numel support is greater than 0? What about numel support equals 0 and OSI equals false? Then what? Use PDHG. And it's going to be this. Is it exactly that? No, because there's no PT. Oh, it was a silly bug. The regularization function I was using was minimizing the L1 norm rather than the L1 norm of the wavelet transform. But it wasn't in any of the code I was developing recently. It's just a silly bug that was around. The image that was coming out was good. So, okay, so now we need concat MFS psi. Oh, it's interesting. This is a subset of this. So now we could just call this. Hmm. Where are you going, Protoss? Anywhere fun? All right. Not enough input arguments. So what is it we're doing now? OSI is not necessarily going to be true. Hmm. It's crashing. It's strange. Oh, okay. It's crashing here. Oh, I'm still providing the support? Okay. I don't know that I wanted to do that, but if I am, this should not crash, right? Oh, oh, okay. Okay. Campus. He's going to campus. And his car is still driving him. Huh. I set OSI to false. Huh. That's strange. Wait, what is OSI? Why is OSI true? I set it to false. Look, OPSI. So weird. Oh, it's false there. Now it's false. Something set to true. Huh. I see. Okay. Looks like there's one issue. MFPT psi PT. MF. What's the point here? We're passing in multiple coils of data. So I guess this would just be if n coils equals 1. That's the only time you do that check. Okay. So it's hard to get it to do. Looks like the adjoint passed. Yep, of concat MFPT. If n coils equals 1 and num support is greater than 0, right, but I even forgot what I was debugging. Okay, so let's make OSI false so that we can come in here. What? Okay. We're not passing in the support. That was what I was checking. No support, OSI is false. Let's see what happens. MRI recon CS not yet implemented. Okay, we weren't doing it for single coil. We were doing it for multi-coil, I guess. lots and lots of bugs. Apply P, what's going on? I'm not passing in a support, so where is apply P being called? What? What on earth was I coding up? Look, this one, I think. End coil is greater than 1. Oh, but no, end coil is equals to 1. No. MFPT. Concat. MFPT, yeah, but then I did concat, MFSI, MFSPT. So I think it's this one. Right, it is this one. Okay. Does this get checked? No. Why doesn't that get checked? Because I'm not doing the right check. Okay, so nominal S maps is greater than 0. Okay. Now we check it. Great, it passes. Multi-coil data S maps O size false. Is that what I did? Multi-coil data O size false. Okay. Recon roamer? What on earth? X naught is 0. Let's change that. Well, I don't know why I have that recon roamer there. I have an X naught. And that was the issue. Okay. Oh my goodness. I have a meeting today at 2 o'clock. Okay. Let's set a timer. And we're running. Things are happening. Okay, this will definitely be the last one I do today. Okay. Ah, okay, good. I did it. We've got lambda S maps, but OSI is false. So that should be the same as this because our psi is actually orthogonal. I don't know if it is or not, but I think that's as far as we're going to get today. Oh, no, those are unused because I commented this thing out, right? Okay. Let's check some stuff in, which we haven't done for a while. And MATLAB once again. Change the font size on it. Okay. What has changed in worklib? Minor changes. This is a big one. Okay. Okay. Oh. Okay. So I'm going to check it. I don't want any of that other stuff. Okay. We're making progress, though very slowly. For a while, we're just going to be like implementing stuff that we know how to implement isn't hard. Looks like we need, if n coil equals 1. We need this one. Okay. With that, we'll end the stream. Making progress. No longer stuck. That's a bit of boredom, and that's not a bad thing. Things are working. See you guys later.